Now, in this video, we're going to look at some of the questions that you'll be asked regarding electricity and magnetism. And specifically, we shall start with how a loudspeaker works. We are going to look how an electric motor works. We shall also look at how a transformer works. These are very common questions as you are preparing for your May June exams. You have to know that. So to begin with, we need to understand that in a magnet, this is actually, we are having two sets of magnets whereby they are placed next to each other according to the law of magnetism. Unlike poles attract and like poles repel. So in this case, we are having attraction between the north and the south pole. Some of the properties of magnetism, magnetic fields that you need to understand, properties of magnetic or electric fields, electric fields that you need to understand. Number one, the fields also always points from north to the south pole. So that's one of the concepts that you ought to remember, that the fields usually point from the north to the south. So if you are going to be given questions whereby you are told to identify the mistakes in the diagram that have been drawn, you have to check whether the fields are pointing from the north to the south. Another property of magnetic fields you need to realize is that magnetic field do not, I'm writing that in bold, do not cross each other. So you need to check if there is a field moving that way and it's crossing another field. That would be very wrong as magnetic field properties is concerned. Next, you need to identify where the fields are strong. Where the fields are strong, the magnetic fields will be straight and very close. So those are some of the properties of magnetic fields you need to remember. They don't cross each other, they point from the north to the south. And now let's focus on how a loudspeaker works. Now, different parts that you need here, which we have the south pole, we have the north pole, and then we have the north pole between here. So what you need to realize at this point, how it works is in that when alternating current flows through here, flow of current results to the production of magnetic fields. So when current flows through the coil that we have here, then it means magnetic fields are going to be created due to the flow of current. So whenever current is flowing through a conductor, you realize that magnetic fields will be created around that particular conductor. But when that has happened, remember this magnet has got also its own magnetic fields, because this is a permanent magnet. So we are going to have a set of magnetic fields. We are going to have a set of magnetic fields. We shall have magnetic field due to the permanent magnet, and also magnetic fields due to the current of that is flowing through this conductor. So what's going to happen is the magnetic fields of the permanent magnet will interact with the magnetic field of the magnetic field that has been created by the flow of current, and this is going to result to a force, and this force is going to make the paper cone to vibrate, hence producing sound. So if you are asked to explain or describe how a loudspeaker works, the first thing you need to identify is that the alternating current that is flowing through this coil is going to create magnetic fields around that coil. And since the paper cone is attached to the coil, then the coil is going to experience a force due to the interaction between the fields of the permanent magnet and the fields due to the flowing current. And this now interaction will exert a force. Imagine you bring two magnets close each other, there is a force. So exactly that's what happened when the magnetic fields of the permanent magnet and the magnetic field due to the flow of current interact, resulting to a force. And this force will make the paper cone to vibrate, which will result to the production of sound. Another part that you'll be asked in your exam to explain, especially is in IGCSE, is how a motor works. Now you see, when current flows through this coil in that direction, what will happen is that when current flows through a coil, there is magnetic fields which will be created around this coil. Now, since here we are also having a magnet, we are having these two magnets. These magnets, they have magnetic fields. Yeah. Now, we have mentioned that when current flows through the coil in that direction, then it means that magnetic fields will be created around the coil. Now, since there is also magnetic fields of the permanent magnet, this is going to make the two magnetic fields to interact. The magnetic fields of the coil through the flow of current, and also the magnetic fields of the permanent magnet. The two fields are going to interact, hence producing a force. And this force is the one that is going to make this coil to rotate. Now, for instance, when we are having this, current is flowing in that direction. So we are going to use Fleming's left hand rule. So such that according to Fleming's left hand rule, it states that if the first finger, second finger, and the thumb are held at right angles to each other, this is my left hand. So the first finger points to the direction of the field, second finger pointing to the direction of the current, then the thumb is going to point to the direction of motion of the conductor. So in this case, I will put my finger in this way. This is the direction of the field. So and then this is the direction of the current. So I have to make my finger point like that. So let me change this current so that it flows in the other way around, so that it can be easy for you to understand this. If suppose we have a negative negative sign and we have a positive, so current is going to flow in that direction. So in this coil, current will flow that way, it will flow this way, and it will flow that way. So that one, it will be easy for me to explain how this works. But otherwise, if you are given a question now, remember Fleming's left hand rule. This first finger points to the direction of the field, the second finger points the direction of the current, and this thumb is going to predict the direction in which the conductor is going to move. So whenever you are given a paper and you have this kind of diagram, indicate the direction of the field, and then you are going to put your hand like that. You see, this first finger is pointing the direction of the field, and this second finger is pointing how current is flowing, and then it means the thumb is pointing upward, so meaning this will rotate in this particular direction. So it means that when current is flowing in this direction, it means point AB will experience an upward force, and CD will experience a downward. This one will experience upward force, but CD will experience a downward force. So this is going to actually rotate like that. It's going to rotate in the clockwise direction. So the moment it has rotated and it has reached the other end, these commutators are going to reverse the current. And once the current is reversed, now this side will be on this side, AB will be on this side, and CD will be on the other side. So this is going to continue rotating in the same direction. So meaning, when you are asked in simple terms how an electric motor works, you are going to say that when current flows through the coil, magnetic fields are going to be created in the coil, around the coil, due to the flow of current. And those magnetic fields are going to interact with the magnetic fields of the permanent magnet. Hence, this will experience a force according to Fleming's left-hand rule. And when we put our finger like this, AB will experience an upward force and CD will experience a downward force. So another common question you'll be asked also is how a transformer works. Remember, a transformer works in the concept that when there's input, AC input in the primary coil, this is actually this is the primary coil, and this is a secondary coil. And something we can mention is that since we have few turns in the primary coil than the secondary coil, it means this is a step-up transformer, because if you have less turns the primary coil and than the secondary coil, this is a step-up transformer because it's going to increase the voltage. So, but that one we're going to discuss later in other videos. But here, what I want to insist is to just explain to you how a transformer works, so I can be able to get rid of this part, and maybe I can maybe write a few points on how a transformer works. So point number one, when AC current flows through the primary coil, and say when AC current flows through primary coil, alternating current flowing through the primary coil, its magnetic fields which are constantly changing direction will be created. So if you are told to explain how a step up transformer works, especially this is a step down up transformer, you will start by saying when alternating current flows through the primary coil, magnetic fields will be created. The magnetic fields created here are constantly changing direction and also changing size. When those magnetic fields are created, they are going to cut through the secondary coil. So magnetic fields will be created around the primary coil. Remember, these two coils are not connected in any way, but the fields which are created in the primary coil are going to be linked by the soft iron core. So the moment the fields are created, they're going to be directed by the soft iron core, and they are going to cut across the secondary coil. And when these fields cut across the secondary coil, then a voltage is going to be induced in the secondary coil. When there is a voltage is induced in the secondary coil through electromagnetic induction, then a current is going to flow in this secondary coil. So in simple terms, if you are asked this question, you need to bring an aspect of magnetic fields being created when there is a flow of current. So if there is a flow of current in this conductor here, then around this conductor there will be a lot of magnetic fields. So that's why I'm saying when alternating current flows through AC flows through this primary coil, magnetic fields will be created around this coil. Then the soft iron core is going to link those magnetic fields to the secondary coil, and in that way, when the fields cut across the secondary coil, a voltage is induced in the secondary coil, resulting to the flow of current.